Hey everybody, this is Mrs. Slauson, one of the Algebra 2 teachers, and I am going to be doing your video for you today since Mrs. Hampton is out of town for a funeral. So we are in section 6.2. I do want to say it's somewhere around page 115, but I've done some editing to this document, so it might not be quite exactly 115, but maybe it's like 114, 116. So just a heads up, look around there. And we are looking for 6.2 log functions and their graphs. So we are going to be graphing log functions. All right. And just a reminder, when we have a log function, it has a base, that's that little sub number, and that would be the base in our exponential version. And just a reminder, b is this base. It's all real numbers. However, this base has to be bigger than 0, and it can't be 1. So just keep that in mind. It can't be 0, or sorry, it's got to be bigger than 0, so positive numbers, and it can't be 1. Okay? And again, b is known as the base. And then x, what's following it, normal size, that's called our argument. And just a reminder, the argument of a log is a positive number. It can't be negative. So kind of some big things to know there when we start graphing. All right, so we showed you in the last section that you could take a log and rewrite it as an exponent, or you could take an exponent and rewrite it as a log. So for instance, if I give you this problem, I could rewrite it as a log by making a capital L out of it. So log with the little base of 2 of 8 equals 3. And then with that, I could take a log problem like, let's do this. And I could make an exponent out of it by doing this loopy e. So 5 to the second power equals 25. All right, whoops, 25, not 55. So just a little review of what we've talked about so far. I am going to go ahead and erase this part. So with that, exponents and logs are inverses of each other. And when they're inverses of each other, they will still have the same common base of b. So the log base b here is going to be the base in my exponent. So you cannot change those. They are going to stay the same. And from first semester, we talked about that when you do have inverses, they actually reflect each other like a mirror over the line y equals x. And just a reminder of what y equals x looks like. Y equals 1x plus 0. I would begin at 0 as my y-intercept, and then I would just have a slope of up 1 over 1. And so we're doing something like this, all right? So that's the line it would reflect over. All right, so we have already discussed in chapter 5 how you graph logs. And so these are very, very basic parent functions. And so basically what happened here is there is a table that's going on. You know, these were the x values we chose. And if you take any of these x values and put them in for here, 2 to the 0 power is 1, 2 to the first is 2, 2 to the second is 4, and then when I do the negative exponents, I just get their fraction forms, and that's this graph right here. And so if you remember, we had a horizontal asymptote at y equals 0, here it is, whether doing 2 to the x or 3 to the x, we've got this horizontal asymptote of y equals 0. And then one of our key points, the y-intercept, went through, unless it moved left, right, up, down, and stuff like that. We had just the basic parent function. It passes through 0, 1 right here, okay? And then we had a domain of all real numbers because our arrows here went to the right, so infinity, and up infinity. And they went to the left here, so negative infinity. But when they tried to go down and we tried to get the y value, they always stopped at this wall of 0. And so it didn't make it on here, but real quick, our domain was all real numbers, negative infinity to infinity, but the range was always 0 to infinity. Again, this is a very basic parent function. So when we add a, or stretch or compress, or if we flip it and it moves left, right, up, or down, these things in this box right here will change, okay? But this is a basic parent function. So with that, when I want to graph their inverses, which are below, then what's going to happen here is everything is going to start to become the opposite. So instead of it passing through 0, 1, it's now going to pass through 1, 0, like here. And instead of having a horizontal asymptote, it's going to have a vertical asymptote at x is 0. Okay. And instead of our domain being this all real numbers, our range will switch to that. And instead of our range having restrictions of 0 to infinity, our domain will. So let's talk about how we get these points on these graphs. So going back to first semester, we talked about that with inverses, that everything is the opposite. And so one of the most basic opposites that happen is that the x and y coordinates of the exponential function flip-flop. So when I'm ready to graph the log functions, the x values become the y values, and the y values can just switch to the x values. And I'll show you how you do this. I mean, this is just a real quick shape of it all. And then I can graph my shape. So I'll go ahead and put the fractions in here, but here's the 1, 0 again. Here's 2, 1. And there's 4, 2. And if I want to get these fractions, over a fourth, down -2, they're going to be like right there. And so this is my shape for log base 2 of x. So let's just recap that in the other one. So if I were making a table for y equals 3 to the x, again, I would use these x values. And when I put 0 in for the x, anything to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9. And then their negative exponents, just move those into fractions. So when I'm ready to graph the log version, I can switch simply. It's one of the things about inverses is x and y. So what will happen is these x values that I'm circling in blue will become the y values. And then the y values will become the x values here. And so just graphing these, I already have the 1, 0, and here's 3, 1, and then 9, 2, and even putting the 1/9 -2 and 1/3 -1, they'd be like right there. And again, this is my shape. So graphing the exponential, if you know how to graph those, which was ICANN number 4, then you can graph the log version, which is going to be your ICANN 6. So these are the basic shapes. And again, the main thing to know here is, again, we won't have a horizontal asymptote. We're going to have a vertical asymptote, and our domain and range switch their jobs. All right, so let's actually practice this. For sake of time, I am not going to do this. I will let Mrs. Hampton go over that with you guys. We're just going to jump right into the graphing. So just a reminder of what all the jobs are. We could see a negative here too, so let's put that in there. A negative means it will flip. Our A will be our stretch or our compress. Our H, remember, we're always going to take the opposite, and that will tell us to move left or right. And then our K will tell us how to move our shapes up and down. So sorry if this is just a little bit different than what Mrs. Hampton did, but it's the same idea. So what we're going to do in order to graph these log functions and state the domain and the range on some of them, we're going to view them as exponential functions. Okay, and the easiest way to do that is to look, I'm going to switch colors here, at this part right here. Oops, that did not work. Hold on, let me get my highlighter back out. All right, sorry, I had to pause the video. I couldn't find my highlighter. So we will look at these as exponential functions. And remember, if the base of a log and the base of an exponent have to be the same, because even though they're inverses, then what I can do is look at this real quick. Here's a little trick when I'm highlighting. Okay, those will become my exponential functions. So what I'm going to do is I'm going to be making a table for an exponential function. And so when I make my initial table, I'm going to look at 2 to the x power. And having those points will help me graph my log function. So if we get started here, here are my x values. And we'll choose those every time, just like we did in ICANN number 4. And if we want to think about this from what we did in chapter 1, then we could look at this as 1 times 2 to the x power, because there's a b value, and then there's our a value. And we told you that this a value, I can get this a little bigger, was where we began. That was like our y-intercept. And then this 2 would tell us to get more points. So I would just start multiplying by 2. So 1 times 2 is 2, 2 times 2 is 4. And then if I'm multiplying by 2 this way, I would divide by 2 this way to get my 1/2 and 1/4. So that's one way to do it. The other way to do it, let me do a little racing, is if we just want to think of this as a very basic exponential function, then when I take my x's and put them in here and do the math to get y, then 2 to the 0 power, sorry about that, is 1. 2 to the first power is 2, 2 to the second power is 4, and then the negative exponents, just move those into fractions. And from here on out, that's how I'll do that, because I think that's just a little bit easier. So what happens now is, because I want the log version, I can make a new table, and if inverses switch x and y around, and exponents and logs are inverses of each other, then I can take the points, my table, and switch the x's and y around. So my x's in pink will become the y's in green, and the y's in pink will become the x's in green, just like this. So I use my knowledge of exponents and the fact that they're inverses of each other to help me get my new table. So I don't need this table anymore. I just want the one that's in green. So those are my points that are going to get me started. And now let's take a look at our transformations. We do have an h value. We want to see it as 3, and that does mean we're going to go right 3. There's no a, there's no stretch or compress, there's no up or down. It's just right 3. So one thing we're going to have to remember is that we still have a wall, and this wall is not horizontal anymore, it's vertical. And how I remember is that the word log, L goes up and down, and that's the way my wall is going to go, up and down instead. So here goes my wall. It's going to start always here. But then when I have things moving left, right, up and down, this wall will be affected, and it's going to go right 3. So it's actually going to end up right here, go over 1, 2, 3, and this is my pink wall. It's going to be, so that's my new wall. And if I want to give this wall a name, it's called x equals 3, because all the x values on this pink vertical asymptote has an x value of 3. So now what I'm going to do is I'm going to graph my points. I'm going to show you the before, and then I'm going to show you the after. So right now my point is starting at 1, 0. It won't stay there. It is now going to go right 3, and it's going to end up in this spot right here in green. And then I'm going to take 2, 1, which won't stay there. It will also go right 3, and I'm just counting over 3. And then 4, 2 won't stay there. It will also go over right 3. And let's talk about the shape. So I'd like for you to come over here, and we're going to make a little table for our shapes. So what does our shape look like? Well, we'll have growth and we'll have decay. And when we write growth, I actually want you to write the word out. Sorry, that's not very neat handwriting. Hold on. Growth. I want you to note the lowercase r, because that's actually, when I connect these shapes, the shape I'm going to get. Growth in a log function looks like a lowercase r for growth, okay? So I will now connect my green points and make this like almost lowercase r to it. All right, that's a little close to my pink wall, but that's okay. Let's go ahead and do our domain and our range. So I just want to get different colors here. So the arrow on the right, it's going right for infinity and up for infinity. But the arrow on the left side, it is going left, but it's going to hit this wall of x equals 3. And the nice thing is when I need to fill out an x and y value, this wall as x is 3 becomes the x coordinate. And then as far as the y coordinate, it's going down and it won't get stopped, so I'll have negative infinity. So when I do my domain, my small x to my big X, I'll have 3 to infinity. And then my range, which is my small y to my big Y, will go negative infinity to infinity. And that is your first one graphed. All right, let's take a look at the next one. So first, let's talk about the transformations here. So we do have a negative, which means it's going to flip. And then we have something inside our parentheses, that's our h. You want to see -4, and that means we're going to be going left 4. So if we want, we can go ahead and get our wall, which is, or vertical asymptote, which is normally here, to move left 4. 1, 2, 3. So it's going to be right here. And so I will now erase, make sure I counted right, this. And this has a wall of x equals -4 because every x value on this wall is -4. All right, let's get our table. I don't have as much room here, so I'm actually going to put the table below. So the way I want to start this, again, is to think of my exponential function because I'm definitely better at x or at exponential functions than y's. All right, so here we go. Choosing these for our x values. And we're going to use 3 to the x power. And the easiest way, again, I think is you just start with 0, and 3 or anything to a 0 power is 1, 3 to the first power is 3, 3 to the second power is 9. And then the negative exponents, just move these as fractions. Now that's my exponential function. I can get the log function table by simply just switching these around. So my x's become my y's, and my y's become my x's. All right, and then these are not the ones I want. I want the ones in green. All right, let's go ahead and get these graphed. So I will start with the nice numbers, not the fractions, and I'm going to be at 9, 2. So let's get to 9, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's actually a little bit off the graph. 9, 2 starts here, and I'm just going to take that and move it left 4. So 1, 2, 3, 4 puts me here in green. And then if I take 3, 1, 3, 1 is here, but then I want to move it also left 4. So that puts me here. Okay. And then 1, 0 is normally here, and then it's going to go left 4. And so what I don't need are these orange points, just the green ones. And so again, growth as a log, because my base is bigger than 1, right, is going to go like this. So I'm focusing on this shape right here. All right, so what didn't happen here? Let me go back, and then let's do our arrows. So this arrow on the right is going right, nothing stopping it. It's going up, nothing stopping it. But the arrow on the left side is going to get stopped, again, when you need to fill out an x and y value. The x value of -4 is what's going to stop it, but it can keep going down, so I'm going to have a negative infinity. So when I do my domain and range, my domain will be smallest x to biggest x, and my range is going to be smallest y to biggest y. And so hopefully what you've realized so far is that our range is always this, and then our wall falls into our domain. All right, next one. So what didn't make it on here is having a base that is a fraction. So what I'd like to do is we are going to change this into log with a base of 1/2 instead, and then x plus 3. So changing the problem on you altogether, and then when I'm ready to make my table, this will be my base, so 1/2 to the x power. Because what we need to do is see what does decay look like in a log function. So let's go ahead and talk about this one. So Just a reminder, this one's out. I just changed the problem on you guys. And when we make our table, I will be using 1/2 to the x power to do that. So again, these will be my x values. And anything to a 0 power is 1. 1/2 to the first power is just itself. 1/2 to the second power, so 1/2 times 1/2 is 1/4. And so if you think about this, these are like dividing by 2, so this way I would multiply by 2, and I would get 2 and 4. And when I'm ready to do my log, right, this is actually what we're making, is the x's will become the y's, and the y's will become the x's. Let's talk about our transformation. So there is no stretch, there is no compress, and there's no, well, sorry, I'm looking back at the other problem and realizing I messed up, which, sorry about that, I should have fixed that, but oh well. This is going up 3 because the number is not in parentheses, so this is addressing k, not h. So our vertical asymptote is going to be stuck here. It's not going to move. So we've got at x equals 0. Okay? So let's figure out what this shape looks like. So decay, let's get a few points and we can finish filling out our table. So as far as decay goes, I'm going to graph my nice points, not the fraction ones. So I'm going to start with 1, 0. And that won't stay there. It's going to go up 3. So it's going to be an orange. And then 2, -1 is not going to stay there. It will go up 3. And then 4, -2 won't stay there. It will also go up 3. 1, 2, 3. All right. And then decay actually looks very much like decay in an exponential function. So decay is still going down from left to right, but it kind of looks like an exponential function. All right, so I don't need the green points, I just need the orange points. So I'm going to get rid of those. Now when we do the arrows here, the arrow on the right is going to the right, so infinity, and it's going down, so -infinity. And when I want to do this arrow on the left side, again, it's going to be stopped by this x value wall of 0, so x gets to be 0, and then this one's going up, and it's not being stopped, so I'll put infinity. So as far as end behavior goes, I didn't leave a lot of room here. I'll do that. Okay, as my function, as x approaches infinity, so I'm looking here, my y value, or my f of x, is approaching -infinity. And then the other one, I'm going to switch to a different color here. And then as I do normally, oh, that's a pretty color there, right? I would normally do x is going to -infinity, but here I notice that I'm going to 0 from the right side. That's what this says. And f of x is going to be infinity. All right, so where did I mess up? So I realized as I was talking, I totally forgot the flip here when I did this. So let me just address that. I'm not going to regraph it. Well, no, I'll regraph it. I apologize. So what happens when we have a stretch or a compress or a flip, we take all of the y values and change those y values by that stretch, compress, flip. So you've seen myself and Mrs. Hampton do this. All of these y's are going to become opposite of what they are. So they're actually going to become +2, +1. 0 is still 0, but now we've got -1 and -2. So with that, I messed up. Let me fix this, get this all erased. None of this is right anymore. Here we go. Sorry about that. Wasn't paying attention. I don't like all these old y values. There's too many numbers, so I'm going to cross them off. And I'm going to graph my non-fraction values. So I'm going to be at 1, 0. So that didn't change. And then it's going to go, let's think about this. So 1, 0 is going to go left 4. 1, 2, 3, 4. Right? And let me make that a different color. Hold on. All right, oh, it's not very much of a different color. And then 3, -1. 3, -1 is going to go left 4. 1, 1, 2, 3, right there. And then 9, -2, which is actually about there, is also gonna go left 4. 1, 2, 3, 4. And then, well, let's see, hold on. Okay, my apologies. Sorry, you guys. 1, 0 is here. I wasn't looking correct. So 1, 0 is here. And then when that goes left 4, I end up here. 1, 2, 3, 4, right there. All right, so here's my shape. So correction, all fixed now. And so this arrow is going to the right. It's going down. This arrow is going left, but the x value of my wall is going to stop it, and it's going up. And then I can do my domain. So my smallest x is -4 to infinity, and my range is -infinity to infinity. So that doesn't change. All right, so let's think about these shapes as they flip. So going back to this, growth looks like a lowercase r. Decay is still decay, like in our previous chapter. And when these flip, things usually flip over the x-axis. So I want you to envision that this is our x-axis right here. And when they flip, they're just going to become mirror images. So kind of like this, mirror image, and like this. So these are the shapes flipped, and I hope I haven't confused you even more. And I'm going to stop this video because it's getting kind of long and I need to take a break, and we will pick up for the next page, which won't take very long, I promise. Okay, so I'll see you in a few minutes.